Good afternoon and welcome to the latest edition of SKC's WebIH webinar series. Our presentation today is entitled Passive Sampling, Concepts, Technology, and Applications. My name is Amber Lesko and I have the pleasure of being your moderator for this session. During the course of today's 30-minute webinar, our technical experts will share the basics of passive sampling, how to calculate sampling rates, and some information on passive sampling technology available on the market and its applications for IH and OEHS professionals. All attendees today will be on mute throughout the session, but of course, we always welcome your questions. If you'd like to submit a question, please do so using the chat box on the right hand of your screen. I'll combine those questions and pose them to our speakers at the end of the presentation. Now, I'd like to introduce our first presenter. Jay Elder has 25 years of experience as a chemist and a laboratory supervisor. Jay joined SKC in 2014 and has been a critical part of the media research team since then. He is currently in the role of research scientist, which allows him to focus on researching both current and new products. Jay, take it away for us here.
Hello, as Amber noted, my name is Joseph Felder, and on our first slide here, we are looking at three types of passive samplers. On the left, we have our 575 series badge for volatile organic hydrocarbons. In the middle, we have a UMAX series badge, and on the right is a thermal desorption tube. Later, Andy will cover these in more in-depth later in this presentation. Moving on, a little bit of passive sampling history. In 1980, DuPont and 3M introduced a charcoal-based organic vapor monitor. In the late 80s, validation guidelines were developed to test and document the reliability of the passive samplers. During this time, new types of passive samplers were being developed, as well as chemically treated sorbents and other specialty sorbents to be used in those samplers. In the early 1990s, SKC research chemists started a program to validate the performance of the SKC 575 series samplers for a collection of various volatile organic vapors. This program continues through today. They were also able to develop chemically coated and specialty sorbents for use in target compounds, and passive samplers are also being used with thermal desorption sorbents for sub-ppb level measurements. A definition: passive sampling can be defined as the collection of airborne gases and vapors onto the sorbent bed at a rate controlled by molecular diffusion through a static air layer. What does this mean? Chemicals will diffuse from an area of high concentration to an area of lower concentration on the sampler, and the rate of this diffusion for individual chemicals can be scientifically determined. The principle of operation. Diffusive sampling involves the movement of molecules across a concentration gradient, which can be defined by Fick's first law of diffusion. Fick's first law of diffusion is a big formula where Q is equal to D times A divided by L times C times T. Q would be the amount of chemical collected on the passive sampler. D is the diffusion coefficient. This is a chemical property unique to the gas or vapor being sampled. A is the cross-sectional area of the diffusive path on the sampler. L is the diffusive path length. This is unique to each passive sampler. C is the airborne concentration, and T is going to be the sampling time. The cross-sectional area, A, is based on the geometry of the sampler, where L is the distance from the diffusive barrier to the sorbent bed. Fick's law, here are some notes. Each chemical being sampled has its own unique sampling rate. The sampling rate is based off of the following factors: geometry of the sampler, which was noted above, and chemical properties for the diffusion coefficient. What are the chemical properties that could be involved? Molecular weight, the boiling point, elements. Is there carbon, hydrogen, sulfur, possibly fluorine, bromine, chlorine? A ring structure. Is it a 3-member ring? Is it a 4-member ring? Is it a 5-member ring? Is it a 6-member ring? And is it aromatic? Plus other properties. Is it an aldehyde? Is it a ketone? Is there a double bonded oxygen in that chemical formula? Fick's law also has limitations, and that is the calculated sampling rate may not always match a validated sampling rate. That is why a validated sampling rate is important. A validated passive sampler. These samplers have undergone studies to verify the sampling rate under a variety of environmental conditions and will provide a higher degree of reliability as needed for compliance and other critical projects. How are we going to sampling rate determinations? Here are some of the equipment we will need to determine the sampling rate. A vapor generation unit. In this unit, we will control all types of environmental factors such as temperature, concentration, humidity, and phase velocity. We will need passive badges, we will need sorbent tubes, and a sampling pump. Here is the calculation for a validated sampling rate. The validated sampling rate is going to be equal to the micrograms of the analyte times 24.46 liters per mole times 1,000. The micrograms of analyte is the mass of the chemical collected on the passive badge, divided by the ppm times the exposure time times the molecular weight. ppm is going to be determined by the sorbent tube. Exposure time is going to range between 15 minutes to 8 hours. And the 24.46 above is the volume to mole constant for a gas at a given temperature and pressure. A little bit about the 575 samplers. They're listed on the catalog and on the website. Some of the information provided for the samplers are going to include validation levels, sampling rate of the chemical, and the desorption efficiency. Here's a picture taken out of our catalog regarding the 575 series samplers. You can see on this table we have validation level, sampling rate, and desorption efficiency. We'll look at the validation levels first. There are various types of validation levels. A calculated rate uses the diffusion coefficient of a specific chemical, the chemical properties, and the cross-sectional area and length of the sampler's diffusion path. As a note, this is not a validated rate, just a calculated rate. A full validation is going to undergo strict NIOSH testing protocols. These could include storage stability studies, reverse diffusion, how that badge is going to operate under different temperatures and humidities, and there's a lot of other testing involved in that. A bi-level validation is the NIOSH testing protocols have been applied to the most volatile member of the related compounds. A partial validation is where the NIOSH testing protocols have been applied to verify just the sampling rate, the desorption efficiency, and the storage stability. Finally, we have OSHA validated rates, or an OSHA validation, which the sampler has been validated and it's actually referenced in published OSHA methods. The second part of the guide that I would like to talk about is the sampling rate. The sampling rate that is about the specific rate of the sample. And the chemical may fall into two categories: a calculated rate or a verified rate, which I covered on the previous slide. A note: if a chemical is not listed in the catalog, SKC will be able to calculate a calculated sampling rate for that chemical. Finally, desorption efficiency. Desorption efficiency is the efficiency of the extraction of the chemical from the sorbent with a solvent. This could be simple, from just a simple carbon disulfide extraction, or it could be a little more complex for a polar chemical, which could be carbon disulfide with N-propyl alcohol. I would like to thank you for your attention and hand it over to Amber.
Awesome. Thank you, Jay. I appreciate that. I enjoyed kind of learning some of the history of it, but then of course, you know, all the great information about validation levels and things like that. That's great. Thank you for sharing that and kicking off our session today. At this point, I'd like to introduce our next presenter, Andy Bragg. Andy is SKC's Director of Customer Support, as well as the Technical Sales Representative for the Southeast. He has over 29 years of experience in the industrial hygiene space and joined SKC 4 years ago. Andy, it's all yours.
Thank you very much, Amber, and thank you, Jay. And good afternoon to everyone, and thank you again for joining us. I want to take advantage of some of Jay's technical information and the history and segue into some additional information about SKC's products and application solutions. But first, I want to cover some frequently asked questions and then discuss the difference between passive and active sampling. So to jump right into some of the frequently asked questions, maybe. There we go. So does the type of sorbent in the passive sampler determine the air or the sampling rate that Jay was referring to earlier? And the answer is no. The sampling rate is determined by the geometry or the design of the passive sampler and the diffusion coefficient of the contaminant. However, the sorbent may affect the possibility of reverse diffusion, but it does not affect the sampling rate. Another popular question is, are sampling rates the same when sampling inside and outside? And this is a great question because I'm sure it comes into play pretty often. The major concern is low air velocity or face velocity. As long as there is some air movement indoors, the sampling rates will be the same inside and outside. But the sampling rates may decline up to 60% if doing air sampling indoors with no air movement. So again, when you're talking about passive sampling, that is definitely something to take into consideration. Another question, how do you determine the sampling rate of a mixture such as petroleum distillates? With mixtures, sampling rates are estimated by using the average sampling rate of the mixture or by selecting a marker compound and using the sampling rate for this compound. So it is definitely not as black and white as a specific compound, but it can be done and is done effectively. Another question, do I have to calculate the sampling rate for the different chemical compounds? And you saw some of the formulas and the things that Jay talked about, so that could be pretty daunting, I would imagine. And fortunately, the answer is no. Manufacturers of passive samplers like SKC provide sampling or uptake rates for the designated chemical compounds. So you do not have to do the math and do the formulas, it's done for you. It's important to be an informed user when you're talking about passive samplers. So know how the sampling rate was determined, whether it was mathematical calculation or by scientific validation. It's good to ask, is a validation report or government agency method to support the data generated by the sampler for your target compound? SKC provides a list of chemicals in which we supply passive samplers along with information on the amount of scientific testing done for each. All that information is available to you at any time. We have the passive sampling guide search function on our website, and also the passive sampling guide in our printed catalog for details on passive samplers and validations done by SKC chemists. So that information is also always at your fingertips and always available. But always remember that we have a very experienced tech support team, as well as scientists and chemists like Jay, who are happy to help as well. So don't ever hesitate to contact us if you don't find what you're looking for at the resources that we provide. So before I go any further and jump into products and applications, I wanted to just take a quick second to make sure that there isn't someone out there listening that doesn't know the difference between passive sampling and active sampling. That may seem elementary to some, but I just want to be sure that everyone understands the advantages to being able to sample using passive samplers if possible. So real quickly and fundamentally, active sampling, or the act of pulling air through the sampling media to gain a sample, you obviously have to have an air sampling pump of some type. You would need tubing to connect the sampling media to the pump, and that could be glass sorbent tubes or filter cassettes, or in the case of this picture, this person is wearing a PPI, or a parallel particle impactor, as the sampling media. And another function that's not shown in this diagram, you would need to calibrate the sampling train. So make sure and connect the pump, the tubing, and the sampling media, and then calibrate it to make sure that you're reaching the required flow. So you have that additional time needed for calibration and setup, but I will say this, technology has come a long way in pumps and calibrators, so this process that used to be quite tedious is not near as difficult today. So then to jump into passive sampling that Jay was describing more so, you see it's much simpler. You basically just have the sampler, and we'll talk about the different types of sampler, but at the end of the day, they're all the same in regards to the fact that there is no pump, no tubing required. It's an extremely simple and convenient process. And it says here that minimal training needed. It is probably in most cases no training needed. Someone would just simply clip it on the lapel or somehow in the breathing zone, and the person would wear it for a designated period of time, and then it would be removed. So obviously it's a much simpler process. And therefore everybody loves the convenience of passive sampling. But at the end of the day, health and safety professionals like yourself need to know if passive samplers generate reliable data. As Jay mentioned earlier in the presentation, in the 1990s, SKC's extensive efforts to set up their validation program, and then OSHA's commitment shortly thereafter to advance the science of passive samplers, ultimately helped advance products like the VOC Check 575 series to the point of being specified in OSHA methods. Here you can see the different options for the 575, whether it be for organic vapors, ethylene oxides, styrene, or methanol. The 575 series offers a very dependable passive sampler option. The 575-002 sampler that you see in there contains anasorbed 747 sorbent, which is very versatile and will allow the collection of polar and nonpolar organic vapors in many cases. So it is preferred by OSHA. But since the sorbent is more expensive than activated charcoal, we also offer a 575-001 with charcoal for organic vapors, as specified in SKC's internal validation studies, where it is appropriate as a cost-saving option. So that's the reason that you see the two different organic vapor samplers. One of the many great things about the 575 is the easy sorbent transfer for analysis. In the bottom left picture of the slide, you can see the little cap in the center right here of the sampler, and that allows for the easy removal by lab for the transfer of the sorbent. So they don't have to disassemble this, they can just take off the cap and transfer the sorbent for the analysis. All right, the 575 passive sampler are identified in 7 OSHA methods as a reliable alternative to active sampling. I want to leave this up on for a minute so that you can look over the different methods and the different compounds. While I do that, I want to take a minute to encourage you that if you're in a situation where you're looking for a solution to the fact that recently 3M discontinued the manufacturing of their 3500, the 3520, and the 3551 badges, we would love to work with you to help get you into the process of getting free samples of sorbent for your desorption efficiency studies. We would absolutely love to be your source for these passive sampling applications. So keep that in mind. And I tell you what, I'm going to be putting a link up on the screen in a moment that allows you to sign up for free sorbent samples. But I've asked Michelle Philby if she is able to right now to also put it up in the chat section. It's a rather lengthy link, so if she can put it in the chat section, you should be able to copy and paste it as opposed to trying to write it down. So Michelle, if you can go ahead and do that, that would be terrific. So below in the middle of the slide, you can see that link that is there, and you can see now what I said is kind of lengthy, but if you could you might be able to do a screenshot here if you wanted to get that link, but please don't hesitate to contact us, and we will get that link to you, or we can work with you over the phone to get those sorbent samples to you. So very quickly, some of the advantages of the VOC check 575 are that depending on which model you order, you will get from 350 to 500 milligrams of sorbent. This is more than twice the sorbent found in other samplers. So what does that mean to you? Well, it means that a second layer is not necessary yet. Even though you don't need a second layer, you will still get up to 2 times the exposure limit, longer sample times, and it reduces the analysis cost and time required since there is just one layer of sorbent. However, it is suitable for 15-minute sales, and as I mentioned earlier, it was designed for easy sorbent transfer so that the lab doesn't have to disassemble the sampler to remove that sorbent. They simply remove the back, as I stated earlier, and pour out the sorbent. Now, this table that I've shown at the bottom shows the desorption efficiency tubes that we make available for doing the necessary DE studies or desorption efficiency studies. This is also what we would be sending you for free right now to give you that ability to evaluate our samplers. So to jump ahead in another line in our passive sampling is our UMEX series. Formaldehyde always seems to bring about challenges, but hopefully we can help you if it has been an issue for you in the past. The OSHA method 1007 for formaldehyde specifies passive samplers such as the UMEX 100 that use paper tape media coated with DNPH. UMEX series is extremely small and lightweight, and you can kind of see here we have a, if I can get my cursor to work, we have a unique sliding cover that allows you to easily expose the sorbent when you're ready to sample and then close it again when you're done. And because of this design also, there is a blank that comes with each sampler. And I want to take a second to say that our stance on the blank is that you don't necessarily need to have every blank analyzed for each sampler, but it is provided if necessary. So we recommend that you consult with your lab to be sure that the proper sampling and analysis is being performed for your application and that you are on the same page. The UMEX 100 meets method 1007 specifications, and we have documented uptake rates or sampling rates for 15-minute to 24-hour and 7-day samples. And there are several other sampling rates available for other aldehydes like you see here at the bottom right of the slide. So it isn't just for formaldehyde, we give you other options as well. In the UMEX line, we have 2 more here for the UMEX 200 for NO2 and SO2. Same design, same benefits. It is the same chemistry as the active OSHA method ID-182. And we have validated sampling of sulfur dioxide and nitrogen dioxide from 15 minutes to 24 hours and validated for 24-hour ambient air sampling for NO2 and SO2 to complement federal EPA reference methods. And then ammonia can be a bear to work with on occasion as well. So our UMEX 300 hopefully can take care of that problem for you. And again, the same design, just the chemistry in this one is similar to the active method OSHA ID-188 and the NIOSH 6016 method. One of the conveniences is that it's safe because it doesn't have any glass or sulfuric acid liquid in the sampler, as with other samplers or other sampling methods. So it also has the enhanced sensitivity with 39.92 milliliters per minute uptake rate for 15-minute, 8-hour, and 24-hour sampling. Many people don't even know that we have a great thermal desorption tube product. So our thermal desorption tubes meet specifications of the US EPA 325A method and benzene uptake rate of 0.67 milliliters per minute. You can use this to analyze collected compound quantitatively using GC or GCMS. You can establish the baseline and manage exceedance levels for benzene, and allows for exceedance sample times for low-level measurements. The two images that you see here are actually the same tube, but one, if you've never used a thermal desorption tube before, one is shown with the required swage lock fittings on both ends, and the other one is shown with a diffusion cap that would be what you would use in the actual sampling process. That end would be porous and allows for the circulation of the compound for the sampling. We also have thermal desorption tubes for other compounds, and this is a list of uptake rates and sorbents for selected Clean Air Act compounds. I just wanted to post this. I know you can't look at it all and document it all right now, but I wanted to put that up there just so that you could see that we do have these TD tubes for other compounds. The last sampler that I want to go into to highlight is the ultra passive sampler. The lab results for the ultra are comparable to canisters for EPA method TO-15, yet there's no cleaning and certification cost. The price is significantly lower, and because of the size and weight, there's no expensive shipping costs either. You have a choice of 5 sorbents for environmental sampling that I show here. It provides a nice passive sampling alternative for EPA TO-17, and again, you don't have to worry about the pump, the tubing, or the calibration. Something that I haven't mentioned with the other badges, and I probably should have, is the high level of sample integrity due to the design and the manufacturing environment. Certainly something you want to think about. These samplers are sonically welded, and they are manufactured in an ultra clean environment, so you can be assured that the sample integrity is protected. The Ultra also boasts higher sampling rates than passive thermal desorption tubes. So I apologize. I know I've thrown a tremendous amount in a very short period of time, but I wanted to get you as much information as I could. We do have other passive samplers and even passive or diffusion colorimetric tubes like the ones that you see below. And of course, our research chemists are always actively working on new concepts in passive samplers. So I encourage you to please visit our website or contact us anytime you have an application that you think might benefit from passive sampling media. So, sorry, did that pretty quick, but I want to thank you very much for your time and for your attention. And I will turn it back over to Amber for hopefully some good answers to questions.
Great. Thank you so much, Andy, and thank you, Jay. And just so everybody knows, you'll receive a copy of this presentation as well as the link to request free samples in an email at some point this week. So be on the lookout for that. And we do have a few questions. So not only do we have our presenters joining us for Q&A today, but we also have 2 other panelists, Cindy Coleman and Chuck Knockreiner. Cindy and Jay, I think I'd like to start with you with this first question. It says, regarding air velocity for passive samplers, if a building has an HVAC unit, is that sufficient enough to generate air velocity for a passive badge? Essentially, what should we be looking for to constitute sufficient air velocity for a passive sampler? Jay or Cindy, would you like to take that one? Jay, you may just, there we go.
Yeah, so as far as the velocity, just somebody walking around would promote enough velocity for the badge. When we talk about zero velocity, it's practically stagnant air, like there's just no movement. So yeah, the AC, you know, the blowing of your AC would be enough.
Perfect. And Cindy, I'll just, if you can hold on there, I have one more. Do passive sample results need to be adjusted for atmospheric pressure at the elevation of the test and temperature at the time of sampling?
No, I don't believe that affects it. You know, all of our testing though is at standard temperature and pressure.
Okay,
but
great.
I don't believe that. I haven't seen it in an OSHA method where they have adjusted for atmospheric pressure.
Perfect, perfect. And I think we have time, we might be able to do one more. And if there are other questions that we haven't gotten the chance to answer, we'll certainly do so afterwards. Andy, let me throw this one your way here. With the UMEX badge, how is the media blank designed? Is it built into all UMEX media?
Good question. And yes, the answer to that is it is built into all the media. So basically you have when the slide is in the open position, that area where the slide is, beneath that there is actually a undisturbed sorbent. So it is in there all the time, whether it's open or closed. It is in an enclosed area, so that when it is sent to a lab, if you need to have that analyzed, they would actually take that badge apart, remove that sorbent, and analyze the blank as well as the exposed part of the sampler. And Chuck, if you're on here, if you want to add to that, if I didn't include everything there.
Yeah, I think the only other thing that I would add, Andy, would be that if you have situations that require us not to put the blank in, I believe we've done that for a couple people, and we'd be willing to talk to you about that. So what I would say is give us a call, and we can talk to you about, you know, maybe 1 out of 10 or whatever it is that have blanks, to potentially lower your cost and potentially lower your lab cost, because I've had some people tell me that if it's there, they got to analyze it. So we'd be willing to work with you any way that you see fit. Just let us know and call us up. Thanks, Andy.
That's great. Well, thank you to both of our presenters. Thank you to all of our panelists, and thank you to everybody who joined us this afternoon. A reminder, you will get a copy of the slides, as well as the link to the free samples for the 575 badges. So be on the lookout for that. And stay safe, everybody, and have a great rest of your week.